A voltaic cell is constructed using electrodes based on the following half reactions. Mg2 plus 2 electrons is going to give us Mg in solid phase, and copper in aqueous phase, the ionic copper, plus 2 electrons is going to give me copper in solid phase. First of all, find out which one is anode, which one is cathode, and second of all, find out the standard cell potential. What we need to do, we need to first of all find out the standard reduction potential for these two half reactions. How do we find it? We need to go and find out the table called standard reduction potential. If you do that, you can find out standard reduction potential for this reaction, which is going to be negative 2.37 volts, and for the second reaction is going to be 0.34 volts. Now we need to figure out which one is anode, which one is cathode. Cathode is the one that reduction happens, and anode is the one that oxidation happens. So electrode in cathode is the one that is stronger oxidizing agent. So how do we figure out which one is stronger oxidizing agent? We need to look for these two numbers. Here we have 0.34, this one has negative 2.37. This one is greater, so it means that this one is stronger oxidizing agent. So that's gonna oxidize the other one. Copper is gonna oxidize magnesium. So cathode is gonna be the copper one, and anode is gonna be the magnesium. So then what we need to do, we need to find out part B, standard cell potential. Standard cell potential can be calculated using this formula. Standard reduction potential in cathode minus standard reduction potential in anode. Cathode, we have it already, 0.34 minus, this one is negative 2.37. So that's going to be 0.34 plus 2.37, because negative and negative cancel out. 2.71 volt, that's the standard cell potential.